Well, the question says, show by completing the square that this expression here, x squared plus 5x minus 10 equal to this. Now, we say that quadratic expressions is of the form ax squared plus bx plus c. Okay, the case that a is 1 is this case. Okay, we need to write it in the form like a. Completing the square means writing the form a open brackets x minus p to the power of 2 plus q. And I will do that by the help of changing c to b over 2 to the power of 2. Okay, so now, as I said, this works if a is 1. Okay, and in case a is not 1, we're going to transform the expression. So in this case, a is already 1. So I'm going to look at the value of b. We can see that b here is 5. Okay, so c will be equal to 5 over 2 to the power of 2, which is 25 over 4. Then I am going to write x squared plus 5x. Instead of me writing 10, I'm going to write plus 5 over 2 to the power of 2 there. Then I know that this is 25 over 4. It's not 10 yet. I want to say to myself, if I have 25 over 4 plus what equal 10, I'll move 25 over 4 over. That makes x is equal to 10 minus 25 over 4. And then this will make 40 minus 25. That makes 15 over 4. Okay, so it means I need to add 15 over 4 to this expression to keep it oh, it was negative 10. Sorry, if it was negative 10, there, this must be 65 over 4. So negative 65 over 4. So over here, it must be, I will add negative 65 over 4. So in other words, minus 65 over 4. Then we're going to take the basis only. Okay. So this will be to the power of 2, and then the sum of the middle term. And then there it's going to be like x squared. And then there's going to be 5 over 2 minus 65 over 4. Proven. Okay. Question 3 says, show that this expression has a maximum of 37. So we do that again by completing the square. Okay. We say that quadratic equation is of the form x squared plus bx plus c. And then we complete the square if we do ax minus p to the power of 2 plus q. And then where c is equal to b over 2 to the power of 2. We need to make c a constant term. This form only when we get rid of the coefficient of a if it's different than 1. Now, in this case, the expression is negative x squared minus 10x, excuse me, minus 10x plus 12. Now, this can be written as negative x squared plus 10x, okay, plus 12, it's going to be minus 12 now. Now, I'm going to look at now I do that because I wanted to have like 1 here or nothing in front of x squared, okay? Then I can apply this property here of making c, which is negative 12, equal, say c equal to b over 2 to the power of 2. Now, I'm going to see here, the b value is 10. So let's do it somewhere there. C will be equal to 10 over 2 to the power of 2, which means 5 squared, which is 25. Now I'm going to write here negative x squared plus 10x, okay? There in the brackets, I am going to write plus 5 squared. But I know it was 12. But now let's show something. I know it was 12, but there is also negative sign here. If I times my negative sign here, this will become what? Negative, let's do it in different color. this would be like negative x squared minus 10x minus 25. But initially, this is negative 25, but initially it was positive 12. So to get 12, I must, how much should I add to negative 25 to get 12? We can do it somewhere aside. Say to yourself like 25 plus what equal 12. So if we move the 25 over, that makes 12 plus 25, x will be equal to 37. So therefore here I will add 37, okay, to make my to make the equation see the same. So over here then I will do I can erase this. I will now do negative I'll take only the basis, okay? It's like x plus 5 to the power of 2, like that, plus 37, okay? It's gonna be like that. This is how I can complete the square, and then the negative will make like negative x plus 5 to the power of 2 minus 37, okay? Well, we have another question here that is show that this expression has a maximum value of 37. Now, we did say that quadratic expression is ax squared plus bx plus c, and then we can, to show the maximum value, we need to write it in the form of completing the squared, okay? And the completed square form is ax minus b to the power of 2 plus bq squared, plus q, sorry. And then this is by the help of changing c to b over 2 to the power of 2, okay? Kind of important property here. Now, this is applied only when the coefficient of x squared is 1. If it's not, we need to make it 1. Now, in this case, I was saying if it's not 1, we are going to make it 1, okay? So in this case, we have like negative x squared minus 10x plus 12. So we're going to write like take negative out, okay? And then this will be x squared plus 10x minus 12. That's the new expression if I make the negative outside. Now the idea was to get a 1 here, so I can apply this property. Then I will look, b is 10, so c will be equal to, I can see here c will be equal to 10 over 2 to the power of 2, which is 5 squared, which is equal to 25, okay? Now this will be negative x squared plus 10x. I will change, instead of me writing negative 12, I am going to write positive 5 squared there. I know this is 25. You know, check this out. If I put the negative back, it will be negative x squared minus 10x minus 25. This is not exactly this expression. The problem is by here. This was positive 12, and there we have like a negative 25. Now, I will say to myself, if I have like negative 25, plus what can make it 12, equal to 12? Now say I'll move negative 25 over, that makes like 12 plus 25 is equal to 37. So if we add, okay, 37 here, then the expression is the same. Now I will rewrite, get back to my calculation. I'm gonna say negative x squared plus 10x, okay, plus 5 squared plus 37 there. Then this will be equal to negative. We can write x there. We'll take only the basis, okay, and the sign of the middle term, like that to the power of 2 plus 37. Now, the fact that we have a negative there, would you say that if a here is lesser than 0, which is lesser than 0, then it would generate a maximum? Now we're going to take this value. This is the value that makes the maximum. This is the Q value here. So the maximum is proven to be equal to 37. We say therefore, the max is 37, proven. Okay. Well, the question says, discuss the nature of the roots of this expression. The nature of the root means we need to tell if it has like unequal roots and if they are real, non-real, rational, or whatever. Okay. So now let's I'm gonna move the -2 over. That makes -x² plus 2x plus 2 equals 0. Okay. Now the roots is determined. The nature of the root is determined by what you call delta. The discriminant delta is given by b² minus 4ac. Then those are exactly the coefficients of the quadratic equation. Okay, so I'm gonna work out delta here. It will be equal to b² minus 4a and then c. Now sub in b is 2, a is -1, and then c is 2. And this is equal to what? That makes 4 plus 8, which is equal to 12. Okay. Now, 12 here is greater than 0. The root here is what? If delta is more than 0, then we said the roots are real, excuse me. Okay, that's the condition. They are real. And then, we can say here, therefore, excuse me, -x² plus 2x equal to -2 has an equal real root. Okay. Okay, I know I did not write it well here. You see here an equal real root. Okay. Question 5 says determine the values of k for which this equation here has real roots. So now this will be like 1 over k equal to x² minus x plus 1. If we times the whole equation by k, this makes 1 equal to k x² minus kx plus k. And then this will be what? Kx² minus kx plus k minus 1. Now, delta will be, okay, determine the nature of the roots. We need to do that by the help of what you call the discriminant delta. It is given by b² minus 4ac. So delta will be equal to b² minus 4ac. And I will sub in the values of b, which is -k, a is k, and then c is k minus 1. Now, this will be what? K² minus 4k², okay, plus 4k. Then this will make like k² minus 4k² will be -3k² plus 4k. Now, when the question says that where has a real root, so meaning 2 roots, this is possible if it is delta will have real roots if it is greater than 0. That's the conditions, okay? Greater than 0. So we can move the -3k over. That makes like 4k will be greater than positive 3k squared. We can just reverse the order now. It's gonna be like 3. Why did I do that? We could factorize, okay? Let's just factorize here. We can take let's take negative k for common factors. So negative k for common factors must be greater than 0. That's gonna be like 3k minus 4. Okay. Now this means this can also mean positive k 3k minus 4 is lesser than 0 if we times the whole equation by -1. Okay. We move the negative, the inequality will change also. So I prefer to work with this. The critical values here are 0. The critical values are the value that makes the expression 0. Okay, it's 0 and 3/4. Okay, it's like to find the critical value, I'm gonna say k 3k minus 4 equals 0. Okay, this means k is 0 or k equal to -4, actually 4/3. Those are the critical values. Now I'm gonna draw the number line. And then place in the critical values there. So the critical values are 0 and 4/3. Now I'll say if I select a number lesser than 0 here, like -1, I sub -1 here, -1 there, I will have a negative times a negative, okay, which gonna make it positive. And then if I take a number like 1, if I sub 1 here and 1 there, it's gonna have a positive times a negative, which will make it negative, and then there it's gonna make it positive. Okay. If I take a number like 2, sub 2 there, positive times positive makes positive. Now I'm looking for a solution where it is negative, so those are open circles. So therefore, k must be between 0 and 4/3. My solution is this one. K must be between 0 and 4/3. Okay. Yeah. Well, we have this expression here. Question says solve for p and then hence solve for x. Now, in this case, let me write the question here. We have like p minus p plus 2 under 2 equal to 13. So I need to make a common denominator. So there I also make a p plus 2 there, and then I times also by p plus 2 by the numerator, and then there also I'll do p plus 2, and then also times by p plus 2. Okay, now that the denominator are common, we can just drop the denominators and then consider the numerator. That makes p plus p times p makes p squared plus 2p minus 2 equal to 13p plus 26. I'll move everything to the left hand side. That makes p squared plus 2p minus 2 minus 13p minus 26 equals 0. Then makes p squared minus 11p minus 28 equals 0. Now factors of 28 are 1 and 28, 2 and 14, 4 and 7. Those are the factors of and then this will be what p there. I will make -4 there and then -7 there equals 0, which means p equals 4 or p equals 7. Now those are the values of p. Now the question B says hence solve for x if this expression equal to 13. But now we can see that all this we can call it, we give it a name, we can call it p, and that's also p, which brings us back to the equation that we have there on A. When they say hence solve for this, you must consider the previous question. So this simply means for B, we can just say therefore x squared minus 4x plus 1 equal to 2, actually 4, or it is equal to 7, okay? Or x squared minus 4x plus 1 equal to 7. So if it is equal to 4, I'll move the 4 over, that makes negative 3 equals 0, and then we can solve this by factorization equals 0. And then that will be x squared minus 4x minus 6 equals 0. You can solve this by factorization. That will make what? Minus 3, minus 1, minus 3. And there it will be for 6 there, factors of 6 will not make 4. So, okay, over here, x can be equal to 1 or x equals to 3. On the other side, minus 6, we have no factor that can make negative 4. So this is type of a prime equation. In this case, we have to use the quadratic formula, and then this expressed by x is equal to minus b plus minus square root of b squared minus 4ac all over 2a. Then this means that x will be equal to minus b plus minus b squared minus 4a and then c all over 2a. B is negative 4, so negative 4, a, and then negative 6, 1 there. We can use a calculator. This will be minus 4 there, 4 there, a is 1, and then c is negative 6 over 2a. So hit equal, that makes 2 minus root 10, and then press SD. So x will be equal to negative 1,6. That's so. No, 1,1 or 1,1, or x will be on the other side, with a positive, so maybe like with the positive here, this will be you press ST there, 5,1. 5,1. Okay, those are the solutions for okay. If you look at this question, B says hence calculate the value of x if this. Okay, we can notice that we can call this whole thing P, okay? Or maybe I can just say, let's say this is P, because this is x squared minus 4x minus 1, and then x squared minus 4x plus 1. So we can call this P, for instance. Or maybe we can just say, oh, this is P. If this is P, for instance, there it's like P plus 2. This part will be P plus 2. Why am I saying that? If you add 2 here in this expression, you're gonna get x squared minus 4x plus 1. Okay, so it's like we have now x squared minus 4x minus 1 equal 4, or x squared minus 4x minus 1 equal to 7, because this is P now. Okay, and then P we find that was 4 or 7. So we can calculate. This means x squared minus 4x minus 3, if I move the 4 over, equals 0. And then we can factorize here. And then say this is going to be like no, if I move the 4, it's going to be like 5 here. It's going to be 5. And then that will make x plus 1, or x minus 5, okay, which means x equal 1 or x equal 5, okay. Now on the other side, if you move the 7 over, it's going to be like x squared minus 4x minus 8, okay. And then factors of 8 are factors of 8 are 1 and 8, 2 and 4. So with factors of 8, we cannot really make a sum which is equal to -4. So over here, we need to apply, this is a prime equation, we need to apply the quadratic formula. So if I now use the quadratic formula, it's going to be like, you know, the quadratic formula is given by x is equal to minus b plus minus square root of b squared minus 4ac all over 2a, okay? So this will make b squared minus 4ac. C is -8 over 2a. So we press there and then we press SD. This is equal to 5.46. Okay. So x equal to 5.46. And then with the negative, this will be with the negative, this will be, you press ST there, it's going to be -1.46, or x equal to -1.46. Now these are the two solutions. Now these are the two solutions for x, okay? The question here says that show that p equal to 3x squared minus 6x plus 12 is positive for all values of x. Okay. I'll look here. 12 is not a square, it's not a square number. So I need to complete. So in other words, here we need to complete the squares, okay? So we are going to write 3x squared minus 6x plus 12 is the same as if we take 3 for common factors, it's going to be x squared minus 2x plus 6, okay? So we complete the square when we write this c is equal to b over 2 to the power of 2. So this will be equal what? -2 over 2 to the power of 2. That makes -1 squared equal to 1. Then that's the c value, and this will be what? 3x squared minus 2x, and then instead of writing 6, I am going to write plus 1 over here. Then note, if I write 1, this will be like 3x squared minus 6x plus 3. But initially it was plus 12. Now we're like plus 3. Okay. I know that 1 is 1 squared. So I prefer to write it like that. So what can I do? Over here, I will write this. 3x squared minus, no, I will write 3 open bracket x squared minus 2x plus 1 squared, okay, a close bracket. I know if because it was 12, there is 3. To make it 12, I need to add 8 to it. I'm supposed to add 8 to it, okay? So over here, I must add 8 to make my inequality, I mean, my equation the same. So this will be 3 open bracket x minus 1 to the power of 2, because you take only the basis, plus 8. Now, the question says to prove that it will always be positive. So we look at this. This part is ax, x is like a squared is always positive or 0. And now multiply by a positive number 3, it will always be positive, okay? And plus another positive number, this will be positive. Therefore, I'll say here, plus another positive number here will make a positive number greater than 0. So that's positive, that was A. And then question B says, hence or otherwise state for which values of x will the square root be real. Okay, so now the square root of this is real if 3x squared minus 6x plus 12 is greater or equal to 0. Okay, so we can, as we factorize this, it was 3x squared minus 2x plus 4 greater or equal to 0. So that, which means it's x squared minus 2x plus 4, which must be greater or equal to 0 because 3 is just a constant number. And then let's factorize if we can. Factors of 4 will not make a sum equal to -2. So over here, we must use the quadratic formula. And the quadratic formula is given by x is equal to minus b plus minus square root of b squared minus 4ac all over 2a. Now, when I use the quadratic formula, it's going to be minus 2. Okay, b is -2. Okay, minus b squared, so -2 squared, minus 4a is just 1, and then c is positive 4. So we make positive 4 there, all over 2a, so 2 times 1. And then, oh, oops, what we get, math error. Okay, yeah, that makes a math error. That's, let's see. B squared, b is -2 to the power of 2. Okay, minus 4, a is 1, and then c is positive 4. Okay, yeah, this makes, let's double check everything is correct. Oh yeah, okay. This means when I hit equal, yeah, it's still giving me math error. Everything is correct. This means that this expression here does not have real roots. Okay. So it wants, it gives a math error. It does not have real roots. You see, even if you do, this is the graph of the expression. You see, it doesn't touch the x-axis. So no real roots here. Remember that a quadratic equation has either 2 roots, 1 root, or no roots at all. So this doesn't have roots. Now we're moving. The question says here, for which values of x will this expression q be non-real? Okay. The expression will be non-real if what is inside here is negative. Okay. So it's gonna be like if x squared minus 5x plus 6 is less than 0. So which means if I factorize here, and then I get it's gonna be factors of 6 that can give me -5 will be -2 and -3. Okay, and then the critical values here are 2 and 3. We can use a number line for that. Draw my number line here, and then let's place values in number line. So values are 2 and then 3. Now in a number line, values of I'll see we have like 3 intervals from -infinity to 2, from 2 to 3, and from 3 to +infinity. So values that are lesser than 2 are like, I can take a number like 0, for instance. If I take a number like 0, I'll sub 0 for x there. It will make a positive because it's going to be -2 times 3 is positive. And this is true for all values in this interval. It's going to be always positive. And if I take a number like 2.5 and then I sub here, 2.5 minus 2 make a positive, 2.5 minus 2 makes a negative, positive times negative makes negative. And then also if I take a 4, it's going to be positive, or any number can take place to make it positive. You can verify it yourself. So therefore, the solution will be in between. So when I say 2 is lesser than x and x lesser than 3, so my solution will be between 2 and 3. Okay. Well, we have another question here that says solve for x and y simultaneously. Okay. I want to use the equation that I think it's easier to solve with. I'll move -x over and then 6 there, and then this is going to be like 2y minus 6 equal x. So this is like equation 2, and that's equation 1. So I can sub equation 2 in 1, and then this will be x squared plus 2yx equal to 3y squared. Okay, I sub in the values of x, which is 2y minus 6, 2y minus 6, and then this will be a minus b to the power of 2 is equal to a squared minus 2ab plus b squared. So this will be 4y, because here my a is that, and then my b is that. So that makes 4y squared minus 2y times 6 plus 6 squared, which is 36, plus now makes 4y squared minus 12y minus 3y squared if I move the 3y squared on the other side. So that makes like 4y squared minus 24y plus 36 plus 4y squared minus 12y minus 3y squared equals 0. Now we can underline like terms. That makes 5y squared, and then negative 24y, that's 24y, and negative 12y makes negative 36y, and we have also 36 there, plus 36 equals 0. Now we have a quadratic trinomial here, or we can use quadratic formula. Okay, it's x is equal to minus b plus minus square root of b squared minus 4ac all over 2a. That's the formula. I was just with the formula, so now we can substitute. B is negative 36, so negative 36 minus okay, square root of 36 squared minus 4a is 5, 5, and then there we have 36 over 2a, which is 5. B squared minus 4ac, and then it's equal, we have like 5 over 6. So this means that y equal to 5 over 6 with the negative. Now for the positive, it will be the positive, it will be 6. So, or y equals 6. Now that we know the values of y, we can find the value of x here. Okay. We do know that if y equal to 5 over 6, then x, which was 2y minus 6, which means x will be equal, we sub 5 over 6 there. It's going to be 10 over 6. So 10 over 6 minus 6. That's going to be 10 over 6 minus 6, which is equal to, I have to move it a little bit like this. 10 minus 36 over 6, which means 26 over 6, which is 13 over 3. That's the value of x. And then x will be equal to 2y minus 6. If I sub 6 there, that makes 12 minus 6. And then x will be equal to 12. Okay. That was question 9. Well, the question says solve for x if this expression is equal to x minus 4. Verify your results. So we have like square root of x minus 2 equal to x minus 4. So situation like this, we need to raise both sides to the power of 2. Okay. And then that will make x minus 2 equal to that's going to be x squared. Okay, let's just do x minus 4 times x minus 4. Okay, because the power of 2 here will cancel this root, and then that will be x minus 2 equal to x squared minus 8x plus 16. Okay, if we extend and then we simplify, so we do this times that, that times that, that times that, and that times that. And then that makes like x squared minus 8x plus 16 minus x plus 2 equals 0. That makes x squared minus 9x plus 18, excuse me, plus 18 equals 0. Now I'm gonna write here 18 and then see the factors of 18 that can make 9. It's 1 and 18, 2 and 9, 3 and 6. So it's only 3 and 6 that can make 9. So we're going to write here minus 3 and minus 3. Minus 3 and minus 6, okay? And then this means that x is 3 or x equals to 6. Now, we cannot just stop here. We always have to see look for the valid answer. So we're going to sub 3 there, verify. I'm gonna say here, verify. Verify. Okay. If x is 3, for instance, it's gonna be like if x is 3, it's gonna be square root of 3 minus 2 is just 1, and then this is -1. So clearly this is not valid. Okay, not applicable. So if, for instance, we had like x was equal to 6, and then that's 6. 6 minus 2 is 4. Square root of 4 is 2. 6 minus 2 is 2. So this is the value. So this is the only solution here. Okay. Thank you. Question 11 says, consider the inequality, this inequality here. The question says why it is a problem to multiply both sides of the inequality by the LCD, the lowest common denominator x plus 3. All right, let's look at the inequality here. It is said that it is less than or equal to 0. Okay, so if we multiply by the LCD x plus 3, if this part is, because the fraction as it is there, it must be to be less than or equal to 0 or to be negative. It's either the denominator is positive and the numerator negative, or the numerator is negative and the denominator is positive. This is how it can make a solution less than or equal to 0. Okay. But now, if at times, assuming that at times this, at times the numerator by the x by x plus 3. Okay. If this is negative, for instance, if at times by a negative number here, it will affect the inequality. Okay. This inequality will not gonna be lesser than or equal, but it will become greater than or equal. Let me give you an example. Let's say at times like 2 over 3. Okay, let's say 2 over negative 3, 2 over negative 3, and negative 2 over 3. Okay, this is lesser than or equal to 0. That's also less than or equal to 0. Now, if at times here by a positive 3, for instance, or by negative 3 over at times here by negative 3, okay, this will change. It will become like negative and negative will simplify, and that makes 6. 6 is not less than or equal to 0. Okay, it's not that, but 6 is greater or equal to 0. Okay. Same also on the other side. If it was the numerator negative and the denominator positive, if at times here by 3, then it doesn't make change in any. If in this case it will remain the same. So that's the same thing here. It depends if x plus 3 is positive or negative. That's the problem. Okay. If it's negative, it will change the inequality. If it's positive, they keep the inequality constant. Okay, and now B says why it is acceptable to multiply both sides by x plus 3 raised to the power of 2. Yes, this makes sense because x plus 3 to the power of 2 is always positive. Always positive. Always positive. So if I multiply here by a positive number, assuming that here, as it was, I multiply here by a positive 3. I multiply by positive, it will not affect the negative, my inequality here, because it's going to be like 6 over negative 3, which is still less than or equal to 0. Okay. So also on the other side, it's still going to be the inequality will still remain the same. Okay. Now question C says by multiplying both sides by that, solve the inequality. Okay. Now let's do it. We're going to multiply the inequality by x plus 3 to the power of 2, x minus 1 over x minus 3, less than or equal to 0 multiplied by x plus 3 x squared. So this side, I can simplify this and that, and now I'm left with x plus 3 multiplied by x minus 1, and then less or equal to 0. So here the critical values here are negative 3 and positive 1. So we can draw a number line to solve the inequality. So in the number line, we place negative 3 and then 1. So and then we see if I pick up any number here in between negative infinity and negative 3, a number like any number, like let's say -4, and then I place like text like 0 and then let's take like 2. If I sub -4 here, I would have a negative number times another negative number, which will make a positive number. And if I sub 0 for x, it's going to be negative. And if I sub 2 for x, it's going to be a positive. So, but my answer is in here, negative, because it is say less than or equal to 0. So therefore, the solution will be -3 less than x, less or equal to x, and less than or equal to 1. So that's the solution. Thank you.